A machine train is a series of machines that are axially connected to each other by their shafts. A typical example is a pump gearbox motor, such as this absorber recycle pump machine train. A multiple machine train alignment is no different than a two-machine alignment in many respects. For example, each machine coupling must be aligned to the required tolerances. All of the standard rules in shaft alignment remain the same, such as factoring in coupling targets, thermal growth, soft foot, and tolerances. The only difference is that all machines in the machine train must be aligned to each other. The tightness of the alignment tolerances is entirely dependent upon the RPM of the machine. In a machine train with a gearbox, each coupling will have a different speed. Most millwrights start with the stationary machine and align each machine down the line to perform a machine train alignment. The problem is that one can only hope that one does not run out of room to move the machines as you go down the line. The reason why this happens is that the position of the first machine dictates the center line for every other machine down the train. This greatly magnifies the misalignment that will be found on each of the next machines. You can avoid this by carefully planning the alignment prior to the moves and corrections, and you will reduce your risk of having to perform inconvenient moves or, worse yet, having to remachine the machine supports or bases to gain more machinery movement, or even having to do the whole alignment over again. One method you can use is measuring the whole machine train alignment and graphing it out. But this is not without its difficulties. You must first graph the actual alignment, then factor in the thermal growth and coupling targets. After that, you must consider the actual allowable movement based on RPM. After that is graphed, you must consider what machines to move, remeasure, and repeat the whole process again. If it sounds like there's a lot to keep track of for a machine train alignment, you are correct. Let's see how this whole process can be simplified and automated. For this example, the Rotoline Ultra IS will be used to align a pump gearbox motor machine train. Machine train alignment begins just like with any two-machine alignment. So make sure you first follow your safety procedures, machine preparation, and soft foot corrections before beginning the alignment. Next, the laser and sensor are installed. Machine train measurement works by individually measuring the alignment across each coupling and letting the Rotoline Ultra IS automatically connect the alignments. For the ultimate in speed and convenience, this alignment will be performed using the multi-coupling feature of the Rotoline Ultra IS. The multi-coupling function allows sensors to be placed at each coupling so that measurements can be taken simultaneously with a single turn of the shafts. The first step in setting up the alignment file is to enter the dimensions for each machine in the dimensions screen. This will let the computer know where each machine foot and coupling is located in order to calculate the alignment and foot corrections to be carried out later on. Next, the speed for each coupling is entered. Notice there is a gearbox in the center. That means that each coupling has a different speed of rotation. Entering the speed in the dimension screen provides the needed information for the Toll Check feature, which will automatically apply the correct tolerances for each coupling. Now is the time to take the first measurement. When you are in multi-coupling mode, all of the measurements are obtained in a single turn of the shafts. There is no need to move the sensor and laser from coupling to coupling. The results are transmitted via Bluetooth to the computer. This provides the same result of the alignment with the targets factored in. The Rotoline Ultra automatically puts these targets in, so you can focus on performing the alignment for each machine. Notice the alignments are also drawn to scale to give you the true perspective of the alignment condition. Because all dimensions for the whole machine train were stored in the Ultra computer, you are now able to determine different machinery correction alternatives by anchoring or fixing various feet of the machine train. By default, the left machine or the pump is fixed as the starting reference because it is typically not moved. In this alignment, you will notice that Rotoline Ultra shows that the pump and gearbox are in fair alignment in both the horizontal and vertical direction. We want to preserve this alignment, so let's just fix the first pair of gearbox feet. As you can see, the motor needs to move in the vertical and horizontal directions by the displayed amounts. What if we could only move the inner feet of the motor because we were bolt-bound on the outer feet? Well, we can just fix those feet and let the Rotoline Ultra perform the move calculations based on those restrictions. The setup of the Ultra now falls in line with the reality of our machine train setup. We need to move the gearbox slightly, which could possibly interfere with the alignment between the pump and gearbox. In the beginning, we entered a lower RPM between the gearbox and pump. Thus, this alignment has a wider tolerance. We can take advantage of that, knowing we will have more flexibility to position our gearbox. This is good to know, but to be sure our motor and gearbox moves will work, we will take advantage of our next tool, the Move Simulator. The Move Simulator allows you to simulate how certain moves will affect your final alignment. To correct the vertical alignment, we need to first move the outer gearbox feet down 3 thousandths, then move the inner feet of the motor down 4 thousandths, until the couplings turn blue and the smiley faces appear. To correct the horizontal alignment, move the inner motor feet to the right 9 thousandths. After the shimming corrections and moves have been made, take another multi-coupling sweep measurement to verify the alignment of the entire train. We have now achieved alignment to coupling tolerances by measuring the alignment in one sweep and predicting a simple, optimized move of only 2 sets of feet in the whole train. Now that the machine train alignment is completed, simply print your detailed full-color alignment report to your flash drive so you can document the successful completion of your alignment.